In Lesson 6-7, we're going to talk about inverse relation and functions. Inverse might be a new term for us, so let's first discuss what that means. If I have a set of relations, or in any relation, I have an element, x and y. I could have 3, -2, 4, 1, 0, 112. Any x and y values. If I want to find the inverse of them, I often relate the word inverse to the word reverse. What that means is I'm going to reverse the x and y values. So now in my relation it'll be -2, 3. That's the inverse. 4, 1 now becomes 1, 4. Those are inverse relations. 0, 1, 12 is now 1, 12, 0. So let's see how this works in one of our problems. In problem 1, it wants us to find the inverse of a relation. I'm going to use a mapping diagram to list out my domain, which are the x values, and the range, which are the y values. So in my original relation, I have -2, 0, 3, and 5. I list out the x's and then the y's. And in a mapping diagram, you only write each number once. So even though there's 4 twice for my y's, I'm only going to write it once. And then I need to map it together. -2 goes with -1, 0 with 1, 3 with 4, and 5 with 4. So to define something as a function, each x can only have one line coming from it. You cannot repeat the x values. So this one is a function. Now let's do the inverse of this relation. Let's reverse the x and y's. My domain is now -1, 1, and 4. My range is -2, 0, 3, and 5. As I map this out, -1 with -2, 1 with 0. Now the 4 goes to both 3 and 5. My x value of 4 repeats itself, defining this as not a function. So just because you have a function, when you find the inverse of it, it may or may not also be a function. Now they want us to graph these both on the same coordinate plane. So let's do the original set of data in red. I have -2, -1, 0, 1, 3, 4, and 5, 4. Here's my original set of data. Now I'll do the inverse data. -1, -2. Now x is 1 and y is 0. X is 4 and y is 3. X is 4 and y is 5. There's my repeated x. That's what makes this not a function. If I analyze the graph of a relation and its inverse, I'll notice between the red and blue line that they mirror each other across the x equals y line. These are the exact same distance when you have a y-intercept of 0 and a slope of 1 to 1. So we can find the inverse or the reverse of a relation. Let's do it now for an equation. I have y equals 3x plus 1. I want to reverse the x and y. So I'm going to have them switch places. put the x where the y was, equals 3y plus 1. Now I want to solve for y. So I'll subtract the 1 from both sides. X minus 1 equals 3y. Divide by 3. And I have that y is equal to x minus 1 over 3. And to designate that this is an inverse function, I superscript a little negative 1. Now that's not y to the negative first. That tells me this is the inverse function of the original problem. So let's compare the two equations for a moment before we move on. In my first equation, I have a plus 1 and a times 3. In the inverse equation, I have a minus 1 and divided by 3. So that's the relationship between the two equations. Let's do one now that has a square. Step number 1, you want to reverse the x and y. So instead of y equals, I'm going to write x equals 1 minus 2y squared plus 5. Now I want to solve for y. I just kind of chip away at this equation until I get y by itself. So the first thing we want to do, subtract the 5. I get x minus 5, 1 minus 2y squared. And that 1 minus 2y, that binomial is stuck together. They're both inside parentheses with the square. So I have to take care of the square next. To get rid of a square, I'm going to take the square root. So I have the square root of x minus 5 equal to 1 minus 2y. Whenever I put a square root into the equation, I have to consider the positive and the negative portion. Solving for y now, I subtract the 1 from both sides. So I have negative 1 plus or minus the square root of x minus 5 equals negative 2y. And my last step, divide by negative 2. So my inverse function, y to the little negative 1, is equal to, I'm going to go ahead and simplify the negative 1 with the negative 2, giving me a positive 1. And I can even split my fraction up. I can write it as 1/2 plus or minus square root of x minus 5 over 2. So last thing I need to address is, are these equations, are these inverse a function? So let's look first at letter A. This one is a function. I have one solution. I have one x that goes with this y. This is a function. If I look at the next equation, when I took the square root of it, I had to consider both the positive and the negative portion. That gives me two answers. If I put in one single x, I'm going to get two different solutions for y. Because that one x goes with two different y's, this is not a function. So if you solve for an inverse and you get one solution, it is a function. If you get two solutions, it is not a function. The last topic we're going to talk about in this portion is just to graph each relation and its inverse, or graph each equation and its inverse. So let's start with graphing the equation that's given to us. I want to first put it in slope-intercept form. y equals negative 7x plus 3. I have a y-intercept of 3, a slope of negative 7. I drew up my graph, so let's start. I start with my y-intercept of 3, 1, 2, 3. From that point, I travel my slope of negative 7 over 1. So I go down 7 and to the right 1. 1, 2, 3, 4, 5, 6, 7, and to the right 1. Connect the two dots with my line. I'll go with pink. And I've now graphed the original equation. So I want to find the inverse of it and graph it on the same coordinate plane. So I want you to practice. Go ahead and push pause and find the inverse of y equals 3 minus 7x. When you're done, resume and check your answer. This is my work finding the inverse. I reversed x and y. I subtracted the 3 over, giving me x minus 3 equals negative 7y. Dividing by negative 7. X minus 3 divided by negative 7 is my inverse. I then split it into two different fractions. So x over negative 7 is the same thing as negative 1/7 times x. That gives me my slope. Two negatives, negative 3 over negative 7, made it positive, and that would be my y-intercept. I then converted them into a decimal because that's easier to graph. So I have a y-intercept of 0.43 and a slope of negative 1 over 7. So let's plot that line. I had a y-intercept of negative 0.43, so that's about at 0.5. I then go down 1 and to the right 7. And that is my inverse. Connect the two lines or the two dots. And remember, the inverse function reflects itself about the line y equals x. It goes through the origin at a 1-to-1 slope. Okay, let's try one more of those where we have a square involved to review how we graph a square or a parabola. All right, on letter B, we have y equals x squared minus 1. So I'm going to graph a parabola. When graphing my parabola, that minus 1 means that I take from my vertex at 0, 0 and go down 1. It's a positive, so I go up to the left and right, and I can draw my parabola. Now let's find the inverse of the function. Go ahead, switch your x and y, find the inverse, push pause while you do your work, and then resume to check your answer. This is my work. I switched x and y. I added the 1 over. To get rid of the square, I took a square root. And whenever I take the square root, I consider both the positive and the negative side. The x plus 1, the one on the inside, tells me to move left 1 unit. And then for a square root, I go up and to the right 1. That's the positive. Down into the right 1. That's the negative. So a square root is just like a parabola turned on its side. So this concludes the first portion of Lesson 6-7.